So we need to find an expression for the transfer function, which is V out over Vn. So V out over Vn will be the same as if we did voltage division right here, where we would take the impedance of the capacitor and the resistor over the total impedance of everything. So the transfer function, which equals V out over Vn, also equals, by voltage division, the impedance of the load over the total impedance. And so the impedance of the load is the impedance of the capacitor in parallel with the resistor, and the total impedance is the impedance of the capacitor in parallel with the impedance of the resistor plus the impedance of the inductor. So this would be, so the impedance of the capacitor is minus J over omega C, and so it's in parallel with the resistor, so that's product over sum over minus J over omega C plus R over minus J over omega C times R over minus J over omega C plus R plus J omega L, and that's the impedance of the inductor. So that is what our transfer function looks like. Now, but that's not in standard form by any stretch of the imagination, so we need to get it into standard form. And so the first thing we can do is to get rid of these complex fractions. So we do that by multiplying by minus J over omega C plus R times minus J over omega C plus R. And then in the numerator, that cancels out, so we get minus J over omega C times R. And in the denominator, it cancels with the first one, so minus J over omega C times R. And then we have plus J omega L times minus J over omega C plus R. Okay, so now what we can do is we can multiply everything by omega C. So omega C over omega C. And then in the numerator, we get minus JR over minus JR plus J omega squared. Nope, I don't want to do that. I want to do J omega L times omega C over minus J omega C plus R. And then when I distribute that, I have minus JR over minus JR plus J omega L times minus J plus R omega C. And then that gets me minus JR over minus JR, and then minus J times minus J times J is minus J squared, and J squared is 1, so minus 1 is plus 1, so that's plus omega L, and then minus J omega squared LRC. Now, this still is not in standard form because we need to have a 1 right here. So I'll multiply by minus, no, I want positive j over r. Positive j over r. Because positive j times negative j is 1. So I get 1 in the numerator. In the denominator, I get 1. And then I get plus j omega L over R. Plus omega squared LC. Now, if I want to get this to look like something where I can find out what the corner frequency is, I want it to look like that. And so I'm going to write this. I need to get that to be, oh, I have a mistake here. This was plus j omega L times r omega c. So this should have been plus j omega squared right there, which would make this minus. Right. Okay, so now to get it into the correct form, I'd have 1 over 1 plus j omega times L over R plus, so this minus here becomes j squared, so j omega over 1 over the square root of LC all squared. So if I check that out, so if I were just to check that out, if I square that, that becomes j squared omega squared over 1 over LC. And so when you divide, you multiply by the reciprocal, so that becomes j squared is minus 1. That's minus omega squared LC. Okay, so then that tells us that omega c, our corner frequency, 1 over the square root of LC, is our corner frequency. And we also know that J, this part right here, J2 C omega over omega C, I'll write that right, J2 C omega over omega C has to equal J omega times L over R. So we know that omega c is 1 over the square root of LC. So J2 C omega over 1 over the square root of LC equals J omega L over R. The J omegas cancel. I can multiply both sides by 1 over the square root of LC. So I have 2c equals L over R times 1 over the square root of LC, or C equals L over 2R, 1 over the square root of L, 1 over the square root of C. So that becomes the square root of L over C times 1 over 2r. So that would be the damping frequency. And then our corner frequency was 1 over square root of LC. Now what were our actual numbers here? 0.1 milli and 1 micro. L is 0.1 milli and C was 0.1 micro. No, just 1 micro, and R was 100. So 1 over the square root of LC is 1 over the square root. So M is 10 to the negative third times 0.1, so that's 10 to the negative fourth. Times C is 1 micro, so that's 10 to the negative 6. So that's 1 over the square root of 10 to the negative 10, which is 1 over 10 to the negative 5, which is 10 to the 5th. So that's our corner frequency. So determine the cutoff frequency. So that's 10,000. And the slope of the magnitude when omega over omega c is much greater than 1. So when we look at our transfer function, when we get it all in standard form, we have it's just 1 over a quadratic pole. So we have 1 over a quadratic pole. So that means once we get high enough that our slope will be negative 20, because it's just going to be the slope, I'm sorry, negative 40, because that's the slope for a quadratic pole. So if I had had a simple 0 over a quadratic pole, if that's what I had, then once I got high enough, my slope would be plus 20 minus 40, which would be minus 20. But that's not what I have. So my slope, as I get high enough, is minus 40.